So welcome to this session. This session, by design, I probably won't get through all of it, but I did want to codify all the best practices, the discussions I've had over the past decade, and in fact longer, talking to thousands of customers. And really, I want to make a point clear is that this session really is for everybody, not just the highest scale customers out there, largest deployments, but even the small environments. And what's been really refreshing and speaking with a lot of you and your peers is that from an automation standpoint, there's still a lot of opportunities. You know, it's really great for users to acknowledge that the infrastructure isn't always optimized and there's always room for improvement. And I spoke to a number of customers this week that's looking for even to automating a handful of hosts, right? In the case where they do need to refresh their hardware, to some customers who are actually deploying thousands of hosts per month. And you definitely don't want to be doing that by hand. And there's certainly, hopefully you get some takeaways, but really, this is really for everybody, for all sorts of environments, from data center all the way out to the edge. Here's the agenda we're going to be taking a look at. Some of the installation method, not only the media boot options for ESXi, kernel boot parameters, as well as configuration. And then we'll take a look at some of the real world applications that I've seen in talking to you and your peers over the years around some of the things that they've had to be challenged with in terms of the constraints, the configurations, and ultimately what solutions were applicable for them. And then I'll cover some tips and tricks. And again, I don't think I'll get through everything. I guess we only get 45 minutes, but I do have all the best practices kind of put in here, and these decks will be available for you after the fact, as well as the recording. So my name is William Lam. I'm a senior staff solutions architect at Broadcom. I want to say VMware. Coming up at 13 years now. You can find me on Twitter and other social media platforms, and you can always reach out to me on my personal blog or just kind of reach out after the fact. So let's take a look at some of the ESXi CLI or ESXi installation options and kind of what those are. Now, as many of you know, you've probably installed ESX or ESXi at some point in your life, probably using an ISO or CD-ROM image. But there's a number of different media options to kind of boot the installation, from USB, using a web browser, as well as NFS and FTP. Now, it's interesting, it's important to understand in terms of when you're booting up the ESXi installation media, that there are sort of two different firmware types that's supported. One is a legacy BIOS option, and typically the infrastructure that's needed for that is using PXE or TFTP infrastructure. It's not the fastest. Usually it's very cumbersome to manage, and in many environments, it's just not allowed for various reasons, and certainly from a performance and scale standpoint. Modern hardware and even our software releases typically prefer and support only EFI booting up, and there's a number of benefits from that. A, we remove the infrastructure dependency, specifically TFTP infrastructure is extremely slow. You know, these are protocols written several decades ago. EFI is quite interesting because you also have hardware enablement, so I can actually take bare metal hardware, provide an HTTP or an HTTPS URL, right, and get the benefit of HTTP. I can cache that, put caching in front of that. It's typically much more faster, and you have a lot more configuration options that's available at your disposal. So you look at modern hardware like Dell, HP, and you go into the BIOS configuration, you should typically see like a UEFI boot, and you basically put in a URL, and I'll show you what that looks like. And you can actually quickly boot up this image of ESXi compared to TFT as an example. So these are just the different kind of boot options. And again, the reason this is important is depending on how you're deploying your infrastructure. Is this a system that you're having to basically plug in a USB key and you want it to completely boot up and self-configure? Is this something that you want to boot over the network and have that automatically configure? Or I have different protocols and access depending on the infrastructure and where they're provisioned at. Another key piece of it is around the bootloader configuration. And again, this is relevant because the changes that you might influence the bootloader configuration, you need to make sure you're editing the right file. This is typically something that is misunderstood. And when you look at when you take the ESXi ISO image and you kind of crack it open and you look at the file system, there are this boot.cfg file, right, that contains the configuration files. And the first level boot configuration, looks like the arrows, so it looks like the format might have messed it up, but where is that? This guy right here. So the first level boot CFG, that's really for legacy BIOS. So if you're doing firmware via BIOS, that's the file that you would edit. For EFI specifically, you would edit the boot.cfg under this EFI/boot directory, right? So if you take any ESXi version, and this has been the case for a decade plus, if you extract that file and you need to make changes, so it's important from that context. Here's sort of a full example of a bootloader configuration file. We have sort of the timeout, and so if you're having to wait for the system to make sure you can kind of hit enter, you can modify the timeout. And then the prefix is interesting because that's basically specifying the URI in terms of where is this media. Is it over HTTP? Is it over NFS? Et cetera, et cetera. This is the kernel runtime option, and so if you want to change different kernel options when the ESXi image boots up, this is where you would apply the configuration. By default, it's going to boot using the interactive installer, but if I want to do Kickstart installation, which is really the focus of this talk, I would modify that. If I want to modify different boot option parameters, disable drivers, et cetera, this is usually the kernel parameter you would influence. And so typically, when you boot ESXi for the very first time, right, you can hit Shift-O and you enter parameters here. That's what that line is basically controlling. So instead of you having to interactively type those parameters, you can actually put those parameters into the file and the system will boot up. Especially at edge deployments, it might take some time to boot the image. So you don't want to kind of fat finger that and have to go through that process again. Here's a more complex example. Here I'm serving my image off of a HTTP server. So you can see I've changed the prefix, and here's the path of the web file directory of my image. It helps to have it to be a little bit descriptive. So here I'm booting, you can probably guess I'm booting off of an 80U3 image. I'm also doing a non-interactive installation, so basically a scripted installation, right? So using Kickstart, and so again, there's some parameters here that specifies I'm gonna do a Kickstart, and I need to specify where is my Kickstart, where is that configuration file that says I'm gonna deploy in this particular configuration and all the different settings I'm gonna apply. And similarly here, we also have different options. So just like earlier, I talked about where you boot the ESXi media, where I'm hosting the Kickstart can also be an alternative location. And we also support the same set of options. It can be from a CD-ROM, a USB, it can be from a web server to FTP as well as NFS, right? So you can imagine if I wanted to boot up an ESXi host off of a USB key, fully self-configured, I would obviously use the USB option. If I wanted to pull down a configuration dynamically from a web server, I can specify that endpoint, and that's where you would influence that configuration. Now, here's a quick sort of high level in terms of a skeleton of what a typical ESXi Kickstart configuration looks like. Oh, sorry. You've got your passwords, you specify your installation, you'll do something with networking. We'll dive into this in a second, but there's some important pieces here around the include, right, where I may have additional files and dependencies that I want to specify. And then we have different stanza here that controls different parts of the configuration process. I have this pre-section that really says, these are the things I want to do prior to installation, and we'll go into some examples of what that is in a second. Then I want to do some things after the installation, so before it goes through its first reboot, I may want to apply some configuration. And then lastly, when the host boots up after it gets installed, I may want to do some operations. And you can see there's an interpreter line here. There's two supported interpreters, Python, so you can write actual Python code in here to do some configurations, or I can use the BusyBox interface and think of that as a basic shell interface. So what are the considerations when you think about your Kickstart configuration, whether you have a static file that says, you know, here's my password, here's I'm going to configure my vSwitches, here's my security policies, to something a little bit more dynamic. So obviously, static file, it's completely fixed. Usually for things like networking, it becomes a little bit inflexible, right? You're going to basically hard code that networking unless you have DHCP as an example. And so depending on your infrastructure configuration, you may want to have a statically assigned IP address, or you may want it to be dynamic. Obviously, it's a little bit difficult to make changes because all of these settings are basically hard-coded in there. It is a little bit easier to manage, right? Because all of those settings is in one single file, right? You boot your media, you specify the Kickstart, it goes install. And in scenarios, what we see there is you may want to have a Kickstart per server. That's a little bit of an overkill, but we do have customers that say, hey, I want specific configuration, and I can source control that. So for this piece of hardware, it's got this configuration, I can source control that, and I can use that. Now, obviously, it also brings up another challenge, is it's around the business logic. If you're going to have a single static file, you might have really complex configuration. You now have a lot of business logic that you have to codify into that single file. If somebody makes a change or they have a syntax error, it gets difficult to troubleshoot. And also, static files may also require multiple Kickstart files, as an example, right? So again, you might have a Kickstart file per server. Now, in the dynamic case, obviously, it's a lot more flexible, especially for networking. I don't need to know networking up front. I can discover that depending on your infrastructure. I can have much more powerful business logic because I can actually take that and codify that in smaller segment files, right? If this host is booting off of this particular location, I might want these NTP servers, I want these DNS servers. It's dynamic, it's no longer fixed, right? Or it boots up from this particular environment, I'm gonna go ahead and pull down this additional configuration and allowing you to really externalize that business logic. And again, it may require additional files, right? But that's one of the benefits of having a dynamic file versus something that you write one time and use. So let me now jump into some of the real world applications and some configuration examples and see if these kind of resonate with you. So in this case, we're gonna take a look at a Kickstart file and we're using an include file. And this is really neat because you can actually specify these files. They don't have to exist yet. And the idea here is that you wanna do something prior to the installation. Now, the most common thing that typically happens is I wanna figure out my networking. Now, if you don't have DHCP, you may wanna say, okay, how am I gonna get the networking on this host to come up automatically, right? And you may have a number of different attributes to kind of quantify that. That might be this MAC address is mapped to this particular IP address, or it's in this particular location, so I'm gonna go and allocate an IP address and pull that in. So you can actually retrieve that dynamically, and I'll show you an example of that. Another common one is storage configuration, right? Maybe for this piece of hardware, it's got these different controllers, these different storage types. Maybe for this configuration, it's gonna run vSAN. Maybe it's vSAN ESA. Maybe I wanna have multiple VMS partitions. I wanna label them in a particular manner. So I wanna retrieve the model, the make, and basically put that business logic in, and then do the output of like, okay, how am I gonna partition that device? And then any other configurations that you might wanna do prior to starting the installation of ESXi. So some common examples is being able to boot from USB and then install that on USB using a static network configuration. So the media comes from a USB device, the configuration comes from a USB device, and I have a fixed IP address. And this is something I've demoed several years back where you have a USB key, plug it into a server, power it on, walk away. 10 minutes later, it's operationally on the network. Another one is using the local disk, obviously, to dynamically retrieve this via a web server. So booting from the USB device, but I'm actually gonna get my network information. I'm gonna get other host configuration dynamically from an external source, right? I can pull that in and then determine how I'm gonna apply that configuration on the system. And then another example is doing the exact same thing, but now I'm configuring more advanced capabilities like vSAN. So the workflow, what that looks like is I've got ESXi media onto a USB device, nothing fancy there, but I've got my Kickstart that's also located on the device. So if you remember earlier, we gave that example. It boots up on the servers. The configuration is actually retrieved from a remote web server, pulls that down to the ESXi host, and goes ahead and configures it. So here's an example of that, right? Where I've got a basic network CSV file, and this can be any file. You get to determine that, right? You get to write the logic, you get to parse the file. So if you want it to be in JSON, have it be if you want to do it CSV or even just a plain text file. And all I have here is basically DNS entries, MAC addresses, IP, gateway, netmask, et cetera, right? And this is a file that I store on a web server. Now, here's a Kickstart, an actual working example that demonstrates that. We create a temporary file called network config, and basically this is gonna get generated based on the dynamic network that I'm gonna retrieve from my web server to say, what address should I basically configure the management network on? We use our pre section, right? And I'm basically downloading this network.csv file onto the host, right? So as you make changes, every time a host boots up, you're always getting the latest copy of that file. Do a little bit of parsing to basically retrieve that, and I'm looking basically at the physical NIC MAC address, and then searching for that in my network.csv file. And then a couple of basic shell scripting lines that basically pull out things like hostname, IP address, netmask, et cetera. And then finally, the last piece of it, sorry if you can't see that at the very bottom, I'm basically generating the Kickstart line that says, this is my network identity, and saving that back into this temp.network config file, which is that same file that I set up here, right? So it reads that kind of top to bottom, and so you can say, you know what, I don't know my networking yet. I'm gonna run some code, some logic to go retrieve that externally, come back in, find that, generate that configuration line, and when ESXi parses that configuration, it's like, I know my identity, let me go install that, right? So just one basic example of that, and this is very common for customers who wanna have a more dynamic infrastructure rather than statically assigning that, and again, from a fixed static Kickstart to a more dynamic infrastructure. Similarly, we can do the same thing for storage. right? Taking a look at the hardware, looking at the device model, the number of devices, you might say, hey, for this server configuration, this is a vSAN deployment. For this other server configuration, I might just use local VMFS. And again, I can use Python. So in this example here, I'm using Python, and I'm basically calling out to a number of VDK and different CLI tools on the ESXi host that basically construct that partition. This might be useful for like bootstrap purposes, right? If you're deploying a brand new greenfield, you have no infrastructure, you need to deploy things like vCenter infrastructure services. Well, you kind of need storage to go about that, right? So you can certainly do this automation first and then go deploy those different components after the fact. Next example is around installing ESXi onto a USB device with a predefined configuration, without relying on external systems, and I want to be able to deploy a set of virtual machines. And this is all coming from the USB device. So there's no network dependency. I'm not only installing ESXi, I'm fully configuring it, but I'm also deploying virtual machines. So the workflow goes something like this. ESXi is on the media. Kickstart, again, is built into that USB partition. Boot that system up. Within this device, it's slightly different than your typical ESXi installation. When you modify the installer, you just kind of put the ESXi media on, and that's typically what boots up. But what you can do with a USB device, especially larger USB devices, you can actually partition that out. And so this is an interesting technique that came from a number of customers who are looking to basically bring back servers within the racks with no external dependencies and always have a known state from a given USB device. And this can be useful for both data center scenarios, which is a customer who I spoke with probably 10 VMworlds ago, to even edge deployments, right? And so what we did here, the technique here was basically taking that USB device, partitioning it up where we place the ESXi media on a FAT16 partition, and then I can actually use another FAT16 partition to hold a service VM that's 2 GB, because there is a maximum in terms of the FAT16 file limit. And then for the rest of the storage, I'm actually using FAT32. And the reason I'm using FAT32 is not because it's the most beneficial file system, but ESXi has the ability to read a FAT32 partition. So you can actually place a number of interesting things into this partition. And again, I can use the Kickstart to process this information and do some interesting things with it. So let me walk you through that. So here's the Kickstart, and I'm doing some enablement of the VMFS modules to basically load it up there. And I've got both my deployment VM, and I've also got the vCenter appliance ISO in that file. And what I'm doing is I'm creating the directory for the service VM. I'm using this mcopy utility that exists on the hypervisor, and what I'm doing is I'm basically copying these various files that I've constructed in that USB device, copying out the service VM, copying out the vCenter ISO installer, and placing them into the vSAN data store that I've just constructed as part of the Kickstart. I go ahead and use some techniques around using cat to basically combine those files, because what I've done is this, if you've deployed vCenter server appliance, you use it several gigabytes. Obviously, we want to slice that up into smaller chunks. I'm using the cat command to basically reconstruct that ISO file. I go in and then unzip this deployment VM. And then what I'm doing is I'm going in and doing some cleanup, deploying this virtual machine, setting up the vSAN namespace, and at the end of that, it automatically mounts the vCenter server appliance, ISO installer, and automatically deploys that. And in fact, this was something that I demonstrated at VMUG back in 2017. Taking a USB key with ESXi, fully deployed, self-configured, add itself into vCenter server. Okay, so now we're going to take a look at the post section of the Kickstart. And again, this is something that you're doing after the deployment. These are all the different things that you can do afterwards, and some of the things that you might want to look at is things like vim command, ESXCFG, local CLI. These are all the different utilities that you would use to typically augment your ESXi host. Now, in more recent releases, starting with 7.0U3 and certainly going to 8.0, we now have a unified way of managing configuration. So rather than going to all these different configuration files and figuring out what is the format and schema, we've unified that against something called ESXi Configuration Store. And you can interact with the system using the config CLI tool. And so some concepts here. So this was introduced in 7.0U1. And there's some concept to be, this is also the basis for our new vSphere configuration profile, which is a technology that will eventually replace host profiles. And so this is sort of the foundational technology that's within our ESXi hypervisor. And it's segmented into this thing called groups, components, groups, and keys. So an example of a component could be like ESX. A group would be like security, and then obviously there's some keys. And you can view the different schemas. And so a neat way to understand the configuration is by using the config store CLI and using the schema list. So you can see here, these are all the different components, right? ESX was one of them. And so once you identify the component, I go and specify that with the -C, and then I can actually see the next level of detail of the different groups. And then ultimately, if I'm interested in, say, the security group, I go and pass that in as another parameter, and now I'm able to see all the different settings that's available. So you can kind of dynamically discover the schema that's available. Now, you can also view this using vCenter. So if you're using vCenter Server and you're playing with the new vSphere configuration profile, we actually visualize that for you, so you can actually see the full JSON specification and see all the different configuration. But if you wanted to kind of discover that, you can. So in this example here, I'm going through the group ESX security settings, and here's what the default looks like. If I wanted to modify one of these settings, what I can do is basically cat out the file, right? And let's say I want to change one of these parameters, the account lock, for example. Let's say I want to change this. What I would do is go in and get the default values, and you can see I'm redirecting out to just a temporary file, right? Kern.json. I go and make that change, and then I now use the set operation, passing in that JSON file. And now when I run that, right? I want it to go from a value of 5 to a value of 6. Now it's changed that. We go ahead and run this configuration. You see the operation was completed successfully. And now when we get that parameter, we can see we've applied that change, right? So if you're making changes to ESXi, especially from a Kickstart perspective, starting with 7.0 8.0, definitely look at the config store because it really simplifies it, puts it into a JSON format. You can source control these configuration, and ultimately you can store these. So you can imagine I can have security policies for different hosts, for different infrastructure. And again, using that remote technology to pull that stuff down, you can then apply it immediately, right? Or you can dynamically figure it out. Based on this environment, these are the values they should be. So it doesn't even have to be a fix. You can turn these into variables. So there's lots of ways of kind of codifying this into your system, right? So we see obviously the value has changed. So here's the vCenter UI screenshot. So if you're using vSphere configuration profile, come into a host, you can then make your changes, and then you can actually see the current values and the changed values. And what's nice about this is that you automatically see what are the different components, keys, and some of these I have blog posts that talks about it, so you can take a look at the short URLs, and they'll give you a lot more information. Okay, the last one we're gonna look at is around the first boot. So basically, after the ESXi hypervisor has been installed, it's gone through a full system boot, I want it to do something. Similarly, I can still leverage all of these different utilities. One thing to note is that in the priors, I talked about local CLI because host D is not up and running, but I still want to augment some of these parameters. I can use local CLI. Once the host is fully booted up, host D is up and running, you can now use ESXi CLI commands. If you try to use it prior, you'll typically get an error. Now, this one's an interesting one. We actually heard from one of our customers say, any VCF customers in here? Awesome. They want to be able to do like zero-touch provisioning, right? And automatically provision the host, configure it based on the VCF specification, and have that automatically added to the host pool within the VCF Foundation system. And today, this is a multi-step. You can use the UI, but we also have an API. And so here's an example, fully working example of how you do zero-touch provisioning for VMware Cloud Foundation today. So again, we're generating some certificates, verifying that host D is up and running. This is actually a full working Kickstart. I go in and open up the firewall rule set because by default we block HTTP. I go in and set NTP, some good stuff here, and then I'm basically retrieving this SCDC manager mapping that basically says, for this host, which SCDC manager instance should I basically put myself into? We then grep for some information, credentials, and then what we're doing here is basically constructing the API request, right, that basically automatically host commission itself into the VCF host domain so that it's automatically ready. So you're basically going from bare metal, fully provisioning, automatically adding itself to the appropriate SCDC manager instance. And you can even take that a step further and automatically create a workload domain based on provision, right? So this is sort of one way to achieve a zero-touch provisioning for your VCF environment. Okay. Let's jump gears over to some of the tips and tricks here. Virtue EFI is really a neat way. One of the things I love doing a lot, and you've probably seen a lot on my blog, is using nested ESXi to really help develop and build out some of this infrastructure. That's actually what I did as a customer, right? As we had new releases of VMware technology, I would download that, install that in Nested ESXi. And one really neat capability is this virtual EFI capability, what I talked about earlier, where you can actually boot off of an HTTP URL endpoint. So if you wanted to do testing, you can actually use Nested ESXi, and the only dependency is basically you just need a web server, right, that serves the media and the ESXi Kickstart file. And then I need to set 2 advanced settings on that virtual machine. So this is that Nested ESXi VM that specifies the boot protocol, HTTP or HTTPS or IPv4 or IPv6, and then ultimately the boot URI. So here's an example of it where I'm basically just using Python to serve up a directory. And in fact, let me jump over to, I think I have a demo. Yep. Yeah, and it basically boots that up. Let me see if I can swap that. Laptop's sleeping. Okay. So here on the left-hand side, I've got basically a directory extracted. It's got my ESXi installation. And what I'm going to do is I'm just going to power it up. And because this is just a VM, right, I've got the media locally on my system. I'm serving that up as HTTP. Hopefully this works. Yep, so you can see that it's immediately booting this up. So this is really cool because A, I'm doing this on Fusion, but you can do this as just a Nested ESXi VM. And so instead of messing with physical hardware, going through the development cycle, trying these different things out, do it in a nested virtualization environment, get your Kickstart fully tested and functional, then go ahead and apply that to your physical world. And so this is a really easy way without any dependencies on the network, right? You're just creating a Nested ESXi VM, have this served up on a web server. In this case, this is just my local desktop, right? And what's even cooler here is that we can also do some fun things here. So here's an implementation, the first time I'm showing this right here, where I'm actually fully booted up into the system. And I'm actually generating a QR code. Now, this could be useful for a number of things like auto registration. I know it's a little bit difficult to see, but what I've done is when this host boots up, it's automatically generating a QR code, a unique QR code that's unique to the system. Obviously, you can snap a picture and you'll get the URL that's supposed to be. Now, in this case here, it's basically looping. It's saying I'm waiting for something, and this is URL. So there's this little file that I need to create. So I don't have anything here. So if I touch this file, it's constantly querying this system on the back end, and it's saying, does this file actually exist, right? If not, it just kind of sits there and waits. So hopefully this works. That's about 10 seconds or so. There you go, works. All right, so a really basic example, right, where you can have the Kickstart do some really complex things and be able to actually interact with that system. And in this case, it's looking for a particular configuration file. So you can imagine things like user input, automatic registration, and other more advanced techniques. But again, it's just an example of what you can do with it, right? Another cool one is around prompt additional user input. You might say, isn't that kind of counterintuitive? I want to be able to deploy at scale, but I'm asking for user input. And we do have customers who have such needs where most of this is automated, but there might be some site-specific details where I still want an operator to be able to input some information. Again, taking advantage of the Kickstart infrastructure, with a little bit of scripting, I can actually prompt for additional user input, right? And then you build in that check-in. So in this case here, I'm prompting for things like hostname, IP address. You probably don't want to type that by hand, but we do have scenarios where operators do need that control. So you have a very dynamic installer with user input, and then that automatically affects the overall deployment. Another useful trick is around custom ESXi boot options. You remember earlier I talked about kind of Shift-O applying different kernel settings. You can actually define your own custom options, right? So here it becomes very flexible if you understand how the system works. You can actually add your own custom key value pairs. And you can actually insert this into the ESXi bootloader option. And then there is this utility called boot option. If you pass it a -O, as you add these parameters, they will automatically be available to you within the Kickstart infrastructure. So here you can start to codify various specific business attributes, configuration settings, have access to those parameters, and deploy it. I think here it says, make sure to rate this session a 10, make sure the audience is happy, right? So there's a lot of interesting things that you can do with that from a configuration standpoint, right? And so it's not just our default kernel settings, but you can also define your own attributes and what that means from a configuration standpoint. Debugging ESXi Kickstart. It definitely can be tricky if you've not done this before. Some really useful thing is that when you create your Kickstart, one of the parameters is this reboot flag. And if you want to test to see if the configuration is operational or not, just remove the reboot from the Kickstart, and it'll go in and apply all of your changes. But then you can actually go into the installer or a nested ESXi VM, press Alt F1, and go in and basically troubleshoot, see what settings were configured, what was missing, go debug it, and then once you've got that figured out, go and update your Kickstart file, reboot the VM, and hopefully it'll address the specific change. The other useful thing too is if you want to quickly get a sense if your Kickstart's going to run properly or not, there's also a useful dry run parameter that you can add into your Kickstart. And what it's going to do is basically parse the Kickstart, check for a syntax error, check for any other issues, and basically tell you like, hey, I don't see anything wrong with it. This should be good to go, right? Especially if you're testing this out on a physical system for the very first time. It takes time to boot the system up, right? And so having this dry run flag can be very, very useful. And these are things I've used myself to really debug and troubleshoot, right? Is that if you're trying to figure out like, I want to make this change and I want it to do it automatically, go into the console, make those changes, make sure that the syntax works, then literally take that and copy that into your Kickstart. It's really that simple. Another interesting one, this is useful for testing purposes. You can actually customize the SMB BIOS, right? And so you can actually mimic the manufacturer and the model. And so you might have different types of hardware types, and it's really hard to test all those different configurations. And so again, leveraging nested ESXi, we can actually modify the BIOS file, and you can actually have custom configuration. And again, full details is in this particular blog post here, but you can change things like asset tags, right? So there are a number of automation that you might say for this particular asset tag, I want to go automatically register that with my iDRAC platform, or I want to go pull down drivers dynamically. So I can look at things like manufacturer, CPU, and pull all that logic in, and then go do something with it. Maybe there's certain hardware where you need additional drivers and VIBs. You can leverage these capabilities, but like, how do you test it? This is one way that you can easily test that without having to depend on physical hardware. So in summary, ESXi is extremely powerful, even in 2024. There's definitely different approaches in terms of how you do your automation. Hopefully you just got a quick taste in terms of all the different possibilities in terms of deploying it from the core data center to opportunities even at the edge, between static, dynamic, and what I typically see customers do is really a combination of the two, is to try to codify as much of the static configuration as possible, and then parameterizing any of the dynamic configuration into separate files. And typically you'll do that for a number of purposes, right? Compliant versus non-compliant infrastructure, site-specific location, and you can use a number of different configurations from like CSV files to JSON configuration file, depending on what you're comfortable with. And ultimately you get to write that code, so you get to decide what is that format, right? And really make it flexible. And ultimately, it's really never too late to automate your installation. Because like I said, lots of opportunity, and I've spoke with even customers who have 1 or 2 hosts, and they really want to automate that because the next time they need to rebuild that, they can do that at scale. And especially when you're looking at deployments at the edge, that's where it becomes really difficult because you don't have a whole lot of staff out there. And leveraging some of these techniques, you're able to fully boot a hypervisor, fully installed, fully configured, compliant, and I can even deploy workloads, all part of that workflow, right? And especially being able to keep that within that USB device. And so I know that there's a lot of organizations that are air-gapped, that need to be firewall between these different infrastructure. Some of these techniques can really help you get to that point, right? So actually, I did get through the session, surprised. So hopefully that was useful. Happy to take any questions. I know we still have maybe 10 minutes left. If anybody wants to ask a question live, happy to take it. If not, thank you very much for attending the session, and I'll be around to answer any questions you may have.